Alright guys, we're still dealing with trying to see if we have congruent triangles or not, but today we might not be given all the information we need. So we got the 5 ways to prove triangles congruent. Again, we're still practicing those. Let's get those written down. That's your side, 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 angle, angle, side, and hypotenuse leg, all with congruence theorem. So you can pause the video if you need to. But now let's check this out. They say A, determine if the two triangles can be proven congruent, so yes or no. If yes, tell us why, and then part C, write the congruent statement. So here on the first one, it's kind of weird, but they don't give us like the tick marks and the arc marks. They give us some distances. So let's put tick marks. Here, this is 5 inches, and this is 5 inches. So we'll put single ticks on that. And here, this is 1.5 and 1.5. So we put different amount of tick marks there. And then on this guy, here's 100 degrees, and that's the same as 100 degrees. So we'll mark those up. And now you can totally see that, yeah, we do have enough information by side angle side on this guy. So that's a yes with side angle side. If I could write, sorry. Side angle side congruence theorem says so. And then we'll write our congruent statement. So triangle, call the first one whatever you want. BUE is congruent to triangle. B goes with R, U goes with T, and Z is our last letter. Make sure we cross our Z's there. So nothing really new on that one. That's all old school, except we did have to kind of put the markings in our picture in that situation. But these next ones are a little different. Like, they're trying to see if these two triangles are congruent. So I'm just going to show you. I got like an orange triangle right here, and I got a green triangle right here. And if I try these 5 ways, I don't have side angle side, side side side, because I don't have enough sides. I don't have side angle side the way it's marked up right now. I don't have angle side angle, and I don't have angle side, nor do I have hypotenuse leg. I don't got none of that going. All 5 ways fail with the way it is right now. But we might be able to check to see if there's more information we could actually prove. That's why at the top of your paper you got this checklist right here, and there's 4 juicy things that we could check for that we know for sure. And I got these ranked in order from easiest thing to do in a proof to hardest, because hey man, next time we're actually going to do the real deal proofs with the T-charts. Today we're doing all the proofs out loud. Like we're not going to write it down, we're just going to do the proof. So here's the first thing to look for. Did you see that when I highlighted these triangles, both orange and green, that this segment right here was orange and green at the same time? It's like shared amongst the two sides. So what we're legally allowed to do is put a tick mark on that. Depending on how many you need, I can use a single tick mark this time, but this side, segment KJ, has to be congruent to itself. And we learned that a while back. It's been a while, but that's because of the reflexive property of congruence. So if we put that on our checklist up there, that's the first thing we're going to check for, to see if there's a shared side between those two triangles. And the reason we could do that is because of the reflexive property of congruence that says anything is congruent to itself. Like I wrote down earlier, segment KJ is congruent to itself. It has to be the same from one triangle to the next. And now if you look, we can totally see, yeah man, it's like side angle side. We got that. So these triangles are congruent by side angle side with a little help from that tick mark. And then we'll totally name the first triangle LKJ, whatever we wanted to call it, and he is congruent to triangle MKJ. So we did not have enough information to prove what we wanted, so we used the checklist. Now I'll tell you what, it's not like that's the only way we could have done it. There are other ways, but they're harder. Like for example, would you believe that this triangle right here is totally isosceles in this case? And we'd have to write that down in our proof. We'd have to say triangle LKM is isosceles, definition of isosceles triangle. Then we could get these guys congruent to each other, because isosceles triangle imply base angles congruent. Then we could prove the triangles congruent by angle side angle. There's lots of ways we could have done this, but I tell you, using this, boom, it was the fastest way to do it. That's why a shared side is #1 on the list. So let's try again. Do I have enough information to prove these two triangles congruent right now? I got this red triangle and I got this blue triangle. Well, let's check. I can't do side, side, side. I don't have any of that. I can't do side, angle, side. I can't do angle, side, angle. I don't have enough angles. Angle, angle, side. Don't got that. Hypotenuse, leg. Not yet. You know, I don't have any tick marks on the hypotenuse. So if we do this out loud today, we'd have to ask ourselves, is there a shared side between these triangles? And yes, there is. So we got to put tick marks, and not just one, but two, because one is already used up. And the reason why we can do that, if we say it out loud today, it'll be so much easier next class period when we have to do this on paper, is that segment Kn is congruent to segment Kn by the reflexive property of congruence. And now, let's see if we have enough. Check it out. Isn't this a right triangle, and isn't that a double tick marks on the hypotenuse? And this is on the leg, so that's yes, man. We can prove these triangles congruent by hypotenuse leg congruence theorem. And then we'll write our congruent statement. Triangle whatever is congruent to K corresponds with N, because that's in the red triangle. K is where one tick mark and two tick marks come together. That goes with where one tick mark and two tick marks come together on the blue triangle. And M is the right angle. He corresponds with J. And N corresponds with K in that case. So you got to be careful to put these in corresponding order. That's a big word that's going to come up next time also, that corresponding. So let's try again. Alright, here's the two triangles. Dude, I got basically nothing right now. And you know, it's kind of weird that we get so optical illusioned. It's like, oh, no arc marks, no tick marks, no nothing. Okay, you're right. But check it out. Isn't this side 3 and this side's 3? So we've got that going for us. We've got a set of sides. And then let's go in order from easiest. The only thing that we know on our checklist so far is if there's a shared side. Yes, there is. So we'll put double tick marks on him. That's nice, right? So we can do that by the reflexive property of congruence. But I still don't have enough info. I don't have these guys, and you can't just put them because you want them. You gotta have a reason, right? It's gotta be on the list of things we could do so you could justify it. So what I do see though is they gave me something else. They gave me these nice cool arrows right here. And don't those arrows mean that these lines are parallel to each other? So if we get parallel lines, we're going to get some angles congruent to each other. So watch this. Let me switch my highlighter to green real quick. And here's what I'd like. If you are working along at home, I think you should highlight these also. Like whenever we're dealing with the parallel lines, it's just a little difficult at first because it's nice to actually highlight the parallel lines. And check it out. Let's see if we can make ourselves a set of arc marks that touch the parallel lines and at the same time touch the same segment for a transversal. So let me get rid of all this other stuff. Let's just talk about those green parallel lines right here. I did have a set of double tick marks on here. Didn't want to erase, but I want to make a set of arc marks that touch the green parallel lines and touch the same segment for a transversal. So watch this. This is not going to work. This is wrong. This arc mark right here, it totally touched a green parallel line, and if I do that one down here, this one touched the green parallel line, but do you see how they touch different segments? This blue arc mark touched this pink segment, and that blue arc mark touched this orange segment. It's like that didn't work. They touched different segments for the transversal. So what if I tried this guy? This dude, boom, and this dude, boom. They definitely touch the same segment. They touch this orange segment, but neither one of these blue arc marks touch the green parallel lines. That just doesn't work right there. So how about this? Does this arc mark right here and this arc mark right here, do they both touch a parallel line, like separately? One of them touches one green guy, one of them touches the other one? Yes, they do. And does the arc marks that we made, do they both touch the same segment for a transversal? Yes, they do. So that's kind of weird. But watch this. I'm going to rotate this for you real quick just so you can kind of see what happened. If I take this dude and rotate him to where we're a little more comfortable, we're comfortable when those parallel lines are running like horizontally instead of vertically. And aren't these guys right here totally alternate interior angles. They're on alternate sides of this orange transversal, and they're between those two parallel lines. So we can legally put those arc marks in there because we have a justification. So if we go up to our checklist, I like to put that as step 3. That's the third easiest way to roll with it, is to check to see if we have any parallel lines. So we had these tick marks, we had this double tick mark, and we just put these guys right here. Parallel lines is something that we could check for, because we have a reason. Parallel lines imply blank. Sometimes it's corresponding angles congruent, sometimes it's alternate interior angles congruent. So it depends on what kind of angles you're dealing with. And in this guy, those are alternate interior angles. So check it out. Now we got to see if we got enough info to prove these two triangles congruent. Don't we have a side, then an angle, then a side in this situation? And don't we do the same thing here? We go side, angle, side. So yes, we do. We do have enough information by side, angle, side congruence theorem. And then we'll call this triangle whatever, RST. That's cool with me. It is congruent to triangle. R is the guy with the arc mark in it in this triangle. He corresponds with T. S is this old guy. He's going to correspond with Q. And then RSTT corresponds with R in this case. So get those in corresponding order. And I can tell you, this gets easier. It just takes a little bit of practice. That one was weird. Those parallel lines. That's why it's number 3 on the list. You know, there's something a little easier than that. So we'll work on this. So let's just see here. Let's try this guy. I got this green triangle right here. I got this blue triangle right here. And they're asking me if I can prove these congruent now. Do I have enough information to just go straight to one of these? Check it out, guys. All of these guys involve sides somehow. This has sides in it, this has sides, this has sides, this has sides, and even hypotenuse leg, those are both sides, they involve sides. And right now in this given information, I don't have any tick marks. So that means I need to go to the checklist to see and start up here. Is there a shared side between those triangles? Bing! Yes, there is. Reason why we can do that is because of the reflexive property of congruence. Now, before we keep going down this list, check to see if any of these are going to work. Since we got a side, we can go angle, angle, side. Hey, that works. Angle, angle, side. And it went in the right order. Double, single side, double, single side. So that works. We have enough info to prove those two triangles congruent. Yes, by angle, angle, side congruence theorem. And triangle TEJ is congruent to triangle FEJ. And guys, I'll tell you, you're right. You know, there's a lot of people in class who say, well, that's not the only way you could do it. Like, isn't this an isosceles triangle because these base angles are congruent, so you could do this? And yeah, you're right. You know, it is an isosceles triangle, but it takes more work in the proof that we're going to write down next class period. You got to prove you got an isosceles triangle. Then you got to say that the base angles congruent imply this, and it's just, it's a lot of work. It's not that hard to say, boop, reflexive property. That's a one-move scenario right there. So let's try again. First, let's see if we have enough info to like prove these two triangles congruent. All of these involve sides and angles, right? Except for this one. This is only sides. I definitely don't have side, side, side. But is this side, angle, side? Nope. Side, angle, skip, skip, side. So that doesn't work. Angle, side, angle. That's got to have two angles with it. I don't have that. But angle, angle, side, I gotta have two angles, but how about hypotenuse leg? Don't we have right triangles in this situation? And we got tick marks on the hypotenuse, got tick marks on the leg, so I didn't even need to go to the checklist on this one. Yes, these triangles are congruent by hypotenuse leg congruence theorem. So triangle ACS, and A corresponds with D, C goes with G, S goes with S. So that was nice. And then finally, the next guy, I kind of got the cheat sheet all filled out for us, but we've probably figured it out on the last one we talked about it, is, hey man, we also know an easy thing is vertical angles in this guy. If there's any vertical angles in the picture, we can use them. But before we like go diving in, I'll let you copy this cheat sheet down. go ahead. The fourth thing on there we've kind of talked about is if there's any isosceles triangles in the picture, and there's all kinds of reasons, like isosceles triangles imply base angles congruent, you got base angles congruent imply isosceles triangle, and you even got the definition. That's why that's fourth on the list, is because, man, that's a lot of stuff right there. That's a lot of things to talk about. He's the last option I want to go to. So after you've paused and written this down, here's our 5 ways. I do not have all 5 of those going for me right now, so let's check, is there a shared side? Because if there was, we'd use it, but there's not a shared side. Like this triangle right here, is blue, this triangle right here is orange, and nowhere did I ever highlight blue and orange right on top of each other. This segment that you're thinking of is not shared because part of it's blue, part of it's orange. It's got to be all blue and orange at the same time. But we're definitely rocking and rolling with the fact that, bro, we got vertical angles here, so let's mark them. Boom, boom, and our justification in the proof would be the vertical angle theorem, and yes, side angle side is rocking for us. So yes, side angle side congruence theorem, and then triangle RQP is congruent to R corresponds with L, Q goes with Q, and P goes with M. So nice. Why don't you pause the video and try this guy for yourself here real quick. When going through this guy, you do not have enough information right now. So checklist, there's not a shared side, but there is vertical angles, and my question for you is, did you mark them? I'll bet you did, but did you put the right amount of markings in there? We need double arc marks because we already had single arc marks. That's going to be our biggest mistake, is we're finally putting the markings, but we got to put the right amount of markings. And then, do we have enough info to prove these 2 triangles congruent? You bet. Angle, side, angle. We could do it again. Angle, side, angle. So that's a yes. By angle, side, angle, congruence theorem, and triangle PLU is congruent to triangle P goes with K, it's got the single, L goes with J, it's got no marks, and U's got the double. So nice. Just a couple more. Let's check this guy out. The 2 triangles here, all I got is these right angles. Okay, I got none of this going on. I got no sides. So, is there a shared side? Yes, there is. We can do that because of the reflexive property of congruence. And now I want to say hypotenuse leg, but I don't have any tick marks on the legs. Right? So let's see if we got any of this other stuff. We got vertical angles. There's none of that going on. I don't have any parallel lines, and I don't have any isosceles triangles. So what happens is students are just so tempted. They're like, well, I want this to happen. I want this to happen, but it doesn't matter if you want it. It's not true. You don't have a reason why this side should be the same as that side. These are our reasons right here. Maybe a couple of other weird little nuggets like we could prove. Like we'll see that on the next problem. But you don't have any reason to put markings on this. So you've went through the 5. You've went through the checklist. You got nothing. Dude, these triangles are not congruent. That's a no. We don't have enough information to prove it. They didn't give me enough. I don't know. So don't try to force something. If it's not on the checklist, it's probably not going to happen unless we do something like this guy. Here's an interesting one. Like, I got me a shared side, so I can mark that. I don't have any sides whatsoever to start with, so I know I got to go to the checklist. I got a shared side, and to get some angles, I want to mark them. I got a 60, the same as a 60. Sorry, my pen messed up there. But one other little nugget that we can use is the fact that if you know 2 angles in a triangle, here's 60 and this is 61, isn't it totally possible to find the 3rd angle by the triangle sum theorem? So this is 60 and this is 61. All 3 of these have to add up to be 180, so this guy right here has to be 59 degrees. And that means over here that this guy has to be 61 degrees in that case. So now I can mark, hey, I got these 59s the same with double arc marks, and that's enough. I don't need to mark the 61s the same. I got angle, angle, side, going single, double side, yes. So we squeezed a little triangle sum theorem in there because that's kind of obvious. It doesn't even need to be on the checklist. But if you're not thinking about it, I get you. So angle, angle, side, congruence theorem. And triangle CGA is congruent to triangle C went with C, B with B, and A with A. So C, B, A. So nice. So a little bit crazier. On the homework it tells you there's 7 no congruences, so make sure that you're not just marking no congruence. Like it's either go through these 5, go through the checklist, and if it's not on there, it should be a no, and there's only 7 of them. So give it your best shot. Let us know if you have any questions. Have a good one.